Hi, everybody. Today we're going to do part 2 of the tutorial of building a weather app using SwiftUI. We're going to be building a loading screen, hourly forecast, and city search. So here's a list of the things we'll undertake within this tutorial. So let's start with the refactor. I'm going to start by creating a separate file for models. I'm going to create a new file. I'm going to select the Swift file. Next, I'm going to call this models. I'm going to import SwiftUI. Then I'm going to cut and paste all the models into that file. I'm also going to separate out all my helper functions. So I'm going to create a new file, also a Swift file. I'm going to call it helpers. I'm likewise going to import SwiftUI, and I'm going to cut and paste these helper functions into the file. You'll notice I have errors for blue sky and gray sky. I'm going to cut and paste the blue sky and gray sky values and paste them here. Now, looking at the code I wrote previously, I've identified an issue. My current approach is to look at words within the description and to try to figure out what the weather is, and then present the emoji and also the background. Unfortunately, this isn't a robust approach, as some of the words I may not have covered, and you might not see an emoji or the incorrect emoji. Looking at the documentation, the right approach is to take the code and then figure out what the weather should be displayed on the screen. So I'm going to refactor my code in order to use code as the basis for presenting the emoji and the background color. I'm going to start by updating my model and extracting the code from the API response. Then I'm going to update my function to accept a code as value. As you can see, we're looking at keywords to determine the emoji. I'm going to comment out the existing code and write some new code. Since the values we're bringing in are integers, I'm going to create a switch command with different cases to handle every single emoji. So I'm going to write switch code, and to quiet this compiler error, I'm going to add a default. Now I've taken the time to go through the JSON to figure out what codes correspond to what emojis. You can do the same process, or you can try copying my code. So the code for a sunny day is 1000. In the JSON, the code for an overcast day is 1003. Here are the codes for thunder and lightning. Here's the code for lightning. Here are the codes for overcast. Here are the codes for rain. And finally, here are the codes for snow. Now that I'm finished my refactor, I'm going to remove this text parameter. And I'm going to remove all the code I've commented out. Now I'm going to use the same process for the background color. I'm going to add a parameter for code. I'm going to comment out my existing logic. And I'm going to use switch case in order to change the color of the screen. So first, I'm going to make my default the gray sky. I'm going to add my default to silence the compiler. In the case that it's sunny or overcast, I want to switch the background color to blue. Now I can remove the text parameter, and I can remove the code I've commented out. Now I need to make changes to the content view because those functions are expecting different parameters. You can see here in the UI that it's expecting a text instead of a code. So I'm going to modify this to accept a code. When I added code to my model, I made a typo and wrote COEE. I updated my model with code, and now code works here. You can see here that the background color is expecting text instead of a code. So I'm going to refactor this piece of code. And likewise, I'm going to do the same for the weather emoji. Now that's it for our refactors for now. The next step is to add a loading screen to make the data loading into the UI smoother. The first thing I'll do is add a loading state variable. I'm going to set it to true because I want the loading state to show first. In my main view, I want to show a spinning indicator when the data is being loaded in, and then show the main UI once the data is available. So I'm going to add a conditional value here. So if the data is loading, then show the loading indicator. Elsewise, we're going to show the main UI. First, I'm going to add a Z stack. Then I'm going to add my background color. Then I'm going to add a progress view, which is our spinning indicator. I've made the progress view twice the size by using the scale effect. I've made the tint white. I made the frame as such so it's centered within the entire screen. And as soon as the progress view loads, then it will fetch the weather. The last thing I need to do is once the UI is updated, once the network request is done, then to set this to false so that the UI can show. So here I'm going to add one line of code, which is loading equals false. So when we run the app on device, you can see the little spinning indicator before the data loads in, which makes it a much cleaner experience. The next step is to add hourly forecast to our app. If we take a look at the weather API JSON, we could see that there's hourly weather reports. So within each forecast day, you'll see an array of hours. In order to access these hourly forecasts, we're going to need to update our models. So I'm going to create a new struct called hour, which I'll make both codable and identifiable because I'll need to iterate through each hour. There's obviously 24 hours in a day, so there'll be 24 array elements. So here are the parameters we're going to extract: the epoch time, the time as a string, the temperature in Celsius, the condition, and also a unique ID, which will be based on the epoch time. This is very much the same approach that we took for forecast day in the first tutorial. Now, the forecast day contains the array of hours, so we're going to reflect this in our model. Now I'm going to create a horizontal scrollable view of all the hourly forecasts. I'm going to place this above the 3-day forecast. The first thing I'm going to do is add the text. Then I'm going to add a horizontal scroll view. Then I'm going to add an H stack. In order to display the hourly forecast, I'm going to need to store the hourly forecast. So the first thing I'll do is I'll add a state variable to store these hourly forecasts. Once the API request is complete, we're going to load in all the hourly forecasts from our models into this variable. So you can see here that we're fetching the hourly forecast based on the first day, which would be index 0, or by some sort of logic to figure out what the correct index should be. Now we're going to write the code in order to add the visual view of all the hourly forecasts. I'm going to add a spacer. Then we're going to iterate through the 24 hours of hourly forecasts. I'm going to add vertical stack. And within this vertical stack, I'm going to add the time, the emoji, and also the temperature in Celsius. In order to display the time correctly, I'm going to have to create a new utility function. Time in the API is represented in this format. So I'm going to create a function that takes the time string represented in military time and returns something like 12 a.m., 1 a.m., 2 a.m., 3 a.m., and so forth. I'm going to initially return a blank string to quiet the compiler. I'm going to set a few variables. The meridian will be set to AM by default. The display time will be 1. The military time will take into account all 5 last digits in the string. In the initial example that I provided, it's 00:00. And the current time will be the prefix to the military time. So it'll be the first 2 digits of the military time. So a special case is if it's noon or it's midnight. So we'll handle that special case. Otherwise, it's not noon or midnight. If it's noon or midnight, then the display time will be 12. If the current time is 00, then it's AM, otherwise it's PM. So in our response, we're going to add the meridian and the display time. Now, if it's not 12, then we need to handle that. The API will return 1 a.m. as 01. So we need the way to convert 01 to simply 1. This condition will return a string 01 to a 1. So if the time is greater or equal to 13, that means we need to show the display time using the current time minus 12. So for example, if it's 1 p.m. in military time, that's 13. Therefore, the display time will be 13 minus 12, which is equal to 1. And the meridian will be set to p.m. Otherwise, if it's in the morning, then the display time will simply be the value that comes in. So the military time, for example, for 5 a.m. is 05. That'll be converted to 5, and the meridian will be a.m. In short, this will convert the military time from 14 to 2 p.m. Now we're going to finish adding our UI. The first thing we'll add in this VStack is the time. Then we'll add the weather emoji. And then we're going to add the forecast. I want to constrain each forecast, so I'm going to set a frame. And then I'm going to add a spacer to the end. So much like we did for the 3-day forecast, I want to add a white blur behind this data. And I also want to set a corner radius. One of the mistakes I made was to write get short time twice. So I'm going to replace this one with the emoji. I'm also going to add padding and a spacer to my hourly forecasts. So if you run it on device, you can now see the hourly forecasts. You can see the UI is a little bit out of balance. So I'm just going to refactor the UI just a little bit to make it nicer. I'm going to add a little shadow to the city name. I'm going to reduce the date from 18 to 16. I'm going to shrink the weather emoji from 180 to 110. I'm going to shrink the font for the current temperature from 70 to 50. And I'm going to shrink the condition text from 22 to 18. For the 3-day forecast, I'm going to shrink it from 22 to 17. And I'm going to add a little shadow to data supplied by. So if we run this on device, you can see the UI is a lot cleaner. The last step is to make our app a lot more dynamic by adding city search. I'm going to add a state variable called query to track what's in the text field. I also need to track the height of the text field relative to the keyboard. When the keyboard shows up, the text field height will change, so I need to keep track of that height. So I'm going to add state variables to track the height and the content size. Now let's add our text field. So I wanted a rounded text field style, so I added a bunch of padding, an accent color of white, and a corner radius of 25. Let's take a look at what this looks like on device. As you can see, the text field is positioned perfectly above the title of the city. Once I type in a city name, upon hitting done or return, I want the UI to change. So let's add some code to do that. I'm going to create a function called getFocus, which will track the height of the text field once the keyboard is shown. My default will be 130. Then I'm going to change the top padding to 130 once the keyboard is shown. So once we hit return or done, what we'd like to do is to call the API to get the city information for the new city we've inputted. So I'm going to make a few changes to the network call. First, we're going to accept a parameter called query. Then I'm going to refactor my code a little bit. If the query is blank, then the weather API will show Scarborough by default. However, if a city name's been inputted into the text field, then that city name will be selected for the API request. Mind you, if this is a production app, it's not really safe to just take user input and directly put it into an API request without doing some validation on it first. So if you want to put this code into production, be sure to add some validation code. Now I need to update every place where this fetch weather function is being called in order to add the query parameter. You can see here I have an error, so I'm going to add the query parameter. I'm going to set it to blank so it shows the default of Scarborough. Then I'm going to add code to my text field. So once the text has been entered, then an API call will be made with the new city. So once you're finished submitting the city that you typed in, then the API will query that city. I've added a little animation in order to smoothly return the text field to its initial position after the keyboard has been withdrawn. I'm going to make a very small change to the blue sky and change the value of our blue color to make it more high contrast. So let's take a look at the results on our app. So now if I type in Los Angeles, I'll see the weather results for Los Angeles. I can type in Tokyo and likewise see the results for that city. I can type in Seattle and see results for Seattle. Thank you so much.